All right, welcome everybody to another Product Spotlight. I am Dave Cooper. What is As Built, you ask? They are a digital engineering experts and one of the largest and most experienced independent specialist building information modeling, BIM as we know it, consultancies in Australasia. I like how they say that, Australasia. As Built has developed unique workflows and customized software that enable stakeholders to align and collaborate in a structured environment and work together from a single information model. Join us as we discuss BIM, the great unlock, digitalizing existing assets, drones, laser scanning. What are the benefits? Mapping spatial site data into useful digital twin, connecting offsite and on-site using the Internet of Things. How do we manage sites better and enhance stakeholder engagement in the visualization? We are going to be bringing all of this together in just a moment, but first we got to thank our sponsors. So big shout out to Ben Hershey and Joe Butler. They are a team with more than 175 years experience developing and specifying manufacturing for panelized and volumetric modular industries. With best practices in development and implementation, they offer consulting with investors, developers, manufacturers, and builders in using offsite manufacturing methods. Forward Solutions is driving companies to succeed where others have failed. For more information, please contact Ben at forwardsolutionsgroup.com. And also thank you to Howick. Howick is a pioneer in the technology of precision light steel roll forming machines. For over 40 years, their commitment to innovation in cold form steel, also known as light gauge steel, precision manufacturing, uncompromising quality, and exemplary customer service have defined the Howick way. Their commitment underpins the competitive advantage enjoyed by their customers. To learn more, visit their website, howickltd.com. All right, so without further ado, let's bring on Craig Lamont, Chief Commercial Officer of As Built, to the show. Craig, how are you, my friend?
Hey, Dave, how you doing?
I know. Hey, listen, Craig is up at the crack of dawn, not even the crack of dawn, middle of the night. It's 2:30 in Australia, right?
Yeah, it's just click 3 in the morning. Yeah, so if you've got to be global, you got to work to the clock, right? So that's cool.
That's right. That's right. Well, listen, Craig, I know we have a presentation to go through. You got some videos to show us. There's a whole lot of information here that I think a lot of people are going to be super interested in. How do we bring the built environment to life is going to be the theme of this conversation. And what are all the different pieces and puzzle pieces, I guess, that you use to make that happen with your software? But first, Craig, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital. And I heard you were real loudmouth in the hospital, or my wife, Jennifer, is going to be calling your mother, and we're going to bring her on the show, and she's going to tell us all the things you don't want us to know. But you only got 2 minutes to do it, so the floor is yours.
Okay. Hey, thanks, Dave. Yeah, that's a true story. My first night in the hospital, I was put in the corridor because I was crying so much I was waking all the other babies. So talking's never been a major problem for me. So thank you very much for the intro. Love it. I'm really excited to be here. Yeah, listen, my life story, I mean, you can read the book a little bit later. It's coming out in a few years' time. It's going to be a bestseller. But actually, fast forwarding past childhood, I grew up in a small town in New Zealand. I went to university relatively young. I'm happy to say that. I went into engineering because I was good at maths, not knowing what I really wanted to do, but just because I was good at maths, one of those great career choices you make in life. I got into telecommunications because I thought it was the future, and so I then studied to become an electronics engineer. Basically, it's really interesting. Production lines and mass production and modern methods of making things have kind of been in my blood all the way through. I grew up on a farm originally, and then after leaving university, I joined a pretty innovative electronics company as an engineer there, doing electronics production. After about 5 years of making battery chargers for telephone exchanges and kind of traveling around the world with them, I moved to the UK, and I was working in the telco field. We're talking 2000, 2001, 2, so around that sort of time. And I traveled around the Europe, Middle East, and Africa, and basically opened my eyes to the world and kind of what was around and what was happening. So the internet bubble burst, to 2002, 2003, things got a bit hard. So I left engineering and went back to production line stuff. So I started a Subway sandwich franchise in London, which was interesting because when I go back to the States, everyone would think that I owned a train line, which is kind of cool. Very the way different language kind of forms. But after the sort of the terrorist bombings there in London in 2007, I decided to move out, and my wife and I moved back to New Zealand. I got back into engineering. I became a project manager because I was good at talking. I did that for about a dozen years, and then left that, joined As-Built, and coming right back here, I'm kind of here to change the world a little bit in my own small way. So that's kind of like my intro story.
Oh, I love it. So you went from Subway sandwiches franchise to As-Built in the built environment of, the building world. And, it's funny as we jump into this presentation in just a moment and learn about some of this stuff. I think people are going to be really surprised to hear one of the comments you made to me before the show when we were talking yesterday. And that is, there's enough digital assets out there. They're just not, really being used the way that's useful to, I think, people in the field. And we're going to talk a little bit about this today. But you really don't really have a whole lot of housing experience, is what I'm hearing. Yes?
No, apart from living in one for most of my life, that's a good start. But no, I've been around construction for a dozen, 15 years. I'm a hands-on kind of guy, so I build a lot of stuff at home. But no, my mass manufacturing experience is really in electronics and production lines and all that sort of theory that goes with that. And then you just apply different fields to different stuff. So I quite often revert everything in construction back to what I know, which is engineering and electronics. And it just allows me to have that sort of language to understand what's going on. So I've been doing construction for 15 years. I'll talk about some of my experience in the presentation. I'm not a complete newbie, but sure, I'm not doing volumetric delivery of bathroom pods at the moment. So this is more the digital side and how we're kind of enabling some of that to come to life, really, which is really, really cool.
I pointed out as a good thing because we need people to be thinking differently about this industry and having that kind of outside the industry approach, because other industries are kicking our butt, with the way that they use data and technology. We just have a different widget, but the principles still apply to us in so many ways. So we're going to hop into that. But right now, Craig, we are live on LinkedIn, YouTube, Facebook, and Twitch. I ask everybody, Craig, why are we live on Twitch? Are you familiar with Twitch?
No, I'm not familiar with Twitch.
Oh, Craig, see, here we go. Twitch is a gaming platform, virtual reality, augmented reality. They have been living in the data and virtual world much longer than we have, especially in our industry. And the young people aren't coming to us. So we decided to go to them, and we're live streaming on Twitch, and we always have people joining us. So if you're on Twitch, hey, let us know who you are and let us know what your channel is, if it's a channel that we would want to follow, of course. And everybody else out there, please hit that like and share button, and please subscribe to our YouTube channel. We are over 100,000 minutes per month watched. That's how YouTube breaks it down. I guess it sounds better that way than hours, but either way, 100,000 is a ton of minutes. So we're loving every bit of it. And if you're not following Craig Lamont, you're wrong. You need to be following Craig, and you need to be following As-Built, but you don't go anywhere until after the show. You follow him after the show. All right, Craig. We got about a 25-minute presentation. Halfway through, we're going to get the comments and questions. Please let us know where you are joining us from today. And also, if you have questions, put a Q in front of it so we can get to it quickly for you. Craig, the show is yours. Go for it.
Yeah, thanks, Dave. I really want to come back to that gaming conversation, if you'd like, at the back end, because it's driving digital, it's driving construction, and that whole immersion of dealing with technology is really something I'd like to chat about if we get time at the end. So I've certainly spent a lot of time inside VR machines. So all right, I've got a presentation for you today. If we just bring that up, cool. So my presentation today is really about enabling the digital playing field. I hope what I shared today has got something a little bit different in there for you. And certainly I'd like to I know I'm already talking to a community of engaged practitioners, but really, this is not really going to talk about BIM or typical digitization stuff. I want to talk about where it's all leading industry. So it's not a futurist piece. what I talk about today is used on projects that As-Built are working on right now.
Great.
We are, yep. I'll be speaking for about 25 minutes. I'll start telling you a little bit about us and what we do. Then I'll share some snippets from our Vault platform and how that and other technologies are contributing to what I call an aha moment, that being of spatial intelligence. Then we'll get on to the main event, really talking about connected construction sites and using the Internet of Things, or IoT. Each section's got some corporate content, but I've snuck a few rogue things in there that are on my mind, and hopefully you'll spot them along the way. So let's begin. We were established in Auckland, New Zealand in 2012. I'm coming to you live from Sydney, Australia, and we're still privately owned. It's a small team currently. We're about 50 plus strong, and we're scaling at some pace in Australia and New Zealand. And we've got our eye on Europe and the US markets, though events of 2020 and again this year have slowed down that immediate growth. We are digital engineering experts and software developers. And so we're one of the largest and most experienced independent specialist BIM consultancies in Australasia. It's a good word. We have an ambidextrous approach to the market, which means our ecosystem really has two parts and one purpose. On the left-hand side, you'll see digital services. We're not going to dwell on these. This is more a presentation on industry change and less on industry participate. And on the right are our products. And I'm not going to linger too long here, except that underpinning our point of truth is Vault. It's that green segment, and we'll be discussing its use in connected construction and as a market differentiator as we go through the presentation. Our right to play has been earned by a diverse team of people. It's interesting that we're a software and technology business, but really that translates for a people business. And our people underpin our culture and our values. This is part of our team, not everyone, but we're really all about being straight up. This is me. I'm an ex-consultant project manager. I got out of management to get back in engineering design because I saw technology as the future of our industry. And then I ended up getting back into management of a different kind and helping to run an exec team which had 950 buildings engineers working for us. So I got back out of there again to go and join As-Built. A little bit more about me. I've been to 57 countries and I've been to the US. I've actually been to 26 states of the US, but it only counts as one country. So all of that experience has given me the right to talk to you and be straight up to you today about what I'm talking about. My background's telecommunications. I've built 3G networks. I've built data centers. I've built maximum security prisons, done land reclamations on foreshores, sawmills for logging timber. I've done an instant noodle factory in Malaysia, built mausoleums, commercial buildings, HV power switching stations, underground rail tunnel ventilation systems, and a lot more. So yeah, I might not have done building so much, Dave, but I've been around in the industry, yeah. I'm doing digital now because I'm genuinely excited about it. In terms of the things that we typically do at As-Built, we've got these more typical fields here, and you can see things like drone capture and point cloud. We have 3D modeling, and we do a lot of fabrication detailing for contractors and construction. We do information or BIM management, and we do immersive communication too. And what you're seeing there is a picture of a 22 feet wide by 7.5 feet high, 360-degree projection mapping studio, which we engage people in, and we've got 2 of those. So by understanding this playing field, we're able to converse across a whole wide spectrum of industry. We do them all, but I'm not going to talk to you about that today. What I want to talk to you about is the concept of 3D and spatial intelligence. And sorry, I'm just catching up on the slides. There we go. And why we use that term and why we believe what we believe it can mean in a sea of change. It underpins our thinking here at As-Built and most of what we do. And we use the principle as the glue which binds our services and software businesses together. Dave mentioned that construction is the least digitized industry, or considered to be one of the least digitized industries out there in the world. It's just a notch above agriculture and farming. It's a really interesting statement because later on this week, I'm talking to an ex-Special Forces soldier who's using drones to map crop growth. So I think agriculture and fisheries and farming is catching up fast. There's parts of construction that are pushing boundaries into advanced manufacturing mindset, and the modularization by the supply chain and concepts of DFMA, just-in-time, modern methods of construction, Kanban, etc., all making huge inroads into certain areas of construction. So many of you on this call will be at the forefront of those boundaries, but the industry as a whole is not digitized. Here's a graphic of productivity gains. It used to have dates, but the dates got boring, so I took them off. But construction productivity over time per worker has actually regressed compared to manufacturing. And it's a statement Dave made, and it might well lose a few people on the call, but I believe that a big reason for the lack of digitization in construction is not the lack of industry uptake in digital. It actually might be the oversubscription of industry to find a silver bullet through digitization. So we might be a product of our own success and using technology to help us get more efficient. All that efficiency is actually working against us.
Interesting. So when you say, Craig, I got a question on that real quick.
Yeah, sure.
So there's enough digital information out there, or digital assets, or software, program, AI, what have you. You're saying that it could be actually working against us because there's so much of it, people can't grasp where to go and how to use it? Is that why?
That's pretty much what I'm talking about. And the next couple of slides are going to go to that very point.
Right,
it's really cool. This concept of a digital playing field is when you look at construction software ecosystem that I've got on the screen now, the challenge is you've got so many platforms, and you would recognize some of the names of some of the programs that are there and some of the areas and fields that they're in. They kind of work together for one reason or another, but they just don't kind of always fit together, you know? And then everyone's got their favorite. So even though this might be better at this thing, I like that. And we hear all that all the time in constructions. But when you look at just platforms, they're everywhere, okay? Well, then when you get into thinking about it from a handover to a facilities or an asset software system, ecosystem, it's a different playing field. And when you look at some of the digital asset platforms there, it's a similar thing. Again, this is not an exhaustive list, but it's not the same playing field that we just came off in construction. So there's a lot of digital in there though, right? So this is what I'm saying. There's a lot of digital stuff out there. And when you put the fields side by side, as I've kind of got here, it starts to become a little bit more clear. The digital construction field is not the same as the digital asset field. The players are different. The rules are different. The length of the game is different. It's kind of like comparing World Series baseball to the Indy 500 and just classifying it under sports. There's a more temporary nature to construction data or data. The data collected there is not often used in the final asset. So there's a fabulous industry graphic which talks about the disconnect between non-digitized systems transferring between project stages, and this sawtooth handover diagram has become an industry norm. And it resonates the issue perfectly, although not necessarily in the way that many people are using it. Digital workflows don't flow as easy as the blue line suggests that they should. But when you think about the compartments between those different industries, you can see, of course, this is what the problem is. We've got this lack of connection between handover. It's kind of like when you think about the fields overlapping, if we switch different playing fields between different quarters in a game, there's no guarantee that you'll get a good flowing game at the end of the day, right? Kind of makes sense. So right. If technology is not at fault, then it must be something else, because if we're using technology but it's still not working, then there's got to be something else. So we genuinely believe that the reference point that we're using to connect across industry might be the problem. Just to think about this in a different context, there's a great saying that is used, data is the new oil. Well, let's look at that. So when people prospect or drill for crude oil, it's destined for eventual consumption, but they might never know the final use or the customer. A later refinement in the manufacturing process adds the value, and the customer ultimately decides whether that's through buying a plastic bottle or they buy a gallon of fuel. The same happens in construction. Like crude oil, data from a construction site itself is quite useless. It has inherent potential, but we must collect it first, enrich it, and then add to it what we want to get from that data that we collected. So when we enrich that data, we call that being useful data, and useful data we call information. We can then take that information and assign it a unique point of reference so it can be found later. and we can correlate and interrogate all those data sets pointed to that specific point. And that's what we call spatial intelligence. Spatially mapped information becomes the linkage across all those platforms, irrespective of the file name. So if you think about that from a contract perspective, it really becomes an agreeable absolute. That this is kind of a language that I started using called data provenance, where we prove what we've got by collating everything that we know about where it is or where it's going to be. This is a interesting graphic that I did for a university actually once, which is kind of coming along that sort of rogue thinking. And I use the term in here, which I'm a bit ashamed about now with the current state of COVID in the world. But imagine yourself in February 2020 and your advancement is on an evolutionary train to peak awesomeness. It's getting better by increments every day. And then a delta shift, there's the language, from COVID is presented. And thanks to Office 365, Zoom, and the cloud, you and your colleagues have gone fully digital. However, without doing anything else different, it's kind of the same journey, really. And that's called a phase shift. So the new normal is still the ticket to play, but everyone has moved as well. Things haven't really changed yet at all. And then we realized that this other kind of paradigm shift trajectory was available. And by mapping everything to a spatial coordinate, X, Y, Z, and a datum point, the point of reference becomes unique. It's a different way to think about what we're trying to do, and we believe it's the right way to think. Sorry.
It's all right.
So let's introduce this kind of innovation, and look, we call it Vault. And this is where Vault plays in connecting the different digital fields. By using a spatial reference connection between the different technologies, we can find that relevant data platform for that platform when we need it. Like the crude oil, the end use of the data is not always apparent, but the spatial location is, and this is a fundamental building block of needed for future consumption. When the data is queried later, the machines can know what something is and where it is or where it will be, so they can report on what might have changed or what might have occurred to it. It's awesome news just for just-in-time, right-time manufacture and ongoing logistics. And when I discovered the Vault, I realized I was looking at a breakthrough on this thing called spatial intelligence. When we start to integrate technology ecosystems, you've got to think about more than just ourselves, though. How does it fit into the wider ecosystem of platforms? You'll see Procore on here that there's been rapidly rolling out across the construction industry. So how does the supply chain then use the tech that we're adding to the process? Does it add or hinder? And you've got to ask yourself that value question. If it isn't adding value, then why am I doing it? And then the supplementary value question is said, if it doesn't add any value in the future, other than to check a current box or a current process, then why am I continuing to do it? And so when I look at Vault, I see projects, and this is kind of what Vault looks like now. I see projects and mapped to my initial screen. And because everything we do is underpinned by spatial intelligence, I want to see where it is on the map. I'm not looking for a file structure or a naming convention to find something. I'm looking for its actual location to find where it is. I'm now showing a simple project through a web-based browser, and top left is a model viewer app. We're using Autodesk Forge. Top right is a point cloud viewer, and I hope that's streaming for you there just briefly, Dave. And bottom left is sort of photospheres and accessible photo viewer, giving you all the details to contain that point cloud, so you can map where in the model you are against what you're looking at on the screen.
Mm-hmm.
Irrespective of the project, these same apps can prevail on different things. So what you're looking at now is a deteriorating railway bridge as a civil example. The spatial intelligence underpinning everything here is we're capturing all the photos from all the site laser scanning that we did to pick up the point cloud picture on the right-hand side and then develop up the model. But we've got a full data record of what we captured when we're at site, and we can look at it to check to build our picture as we're going. And then this is something else of real interest when you start thinking about connecting facilities. So this is the Melbourne Cricket Ground, and we interrogate here how the stadium is performing on game day, and from the existing spatially located IP cameras and data sets that they've got. Once located, we can assign other data streams to them. So the graphic on the left-hand side there that's measuring the bays as the people are moving in, sitting down, getting ready for the game. This is awesome because we're now starting to collect that sort of journey map of the punter going to the stadium, and so we can compare now and rewind and rewatch. How does the stadium perform at 50,000 versus 100,000? And when you think about a construction site, we can do this sort of stuff going forward as well. I've got a little video at the end of the presentation to show you more on that Melbourne Cricket Ground. It's really interesting, but I'll head back to construction.
Well, let me ask you, before we go on to some of this stuff here, and we're going to go to some comments as well, but how does this data get in there? Like, how do you monitor people in real time filling in their seats? I mean, think about this, right? It's the same concept of how do you monitor a job site in real time and what's going on there? And then how does all of this information make a difference to the organization that's actually either building it, financing it, et cetera?
Yeah, look, I mean, the camera footage has been captured anyway, security cam feeds, and, guys are watching their sites anyway because they want to know where people are at, if things are, access areas are controlled or whatever they might be. So the data streams are already being collected, yeah? What we're doing with Vault is actually tying those streams together, that you're saying, well, that camera feed looking at that location is also picking up a lot of other data that we could be capturing and using. And maybe we've got another platform over here that could use that same feed. If we connect those 2 points, then suddenly we're using that same data feed in a different way. By going back and playing it, we can use AI, we can use machine learning to review that data ongoing and look for things that we're learning as we're building our construction sites of the future, going, right, we know that when we stick that crane there, that truck can't get through. Logistics, mapping, various other things. This is where we need to be able to play back data sets. If we're mapping it not just based on experience, right, but actual evidential proof, we're starting to really unlock how we can make construction sites work better.
Yeah, I mean, I could see that already, even in the off-site world. I mean, if a crane pulls somewhere and all the trucks with the modules and kit of parts can't get in, well, that's a big delay, which costs money and time and everything else. So you're saying you can capture all this data from history and other projects and bring them all into existing projects, so you can map out what's not only happening now, but what the future looks like?
Yeah, and I'm going to explain that in the next segment as we go through. But yeah, absolutely. And actually, what it's doing is it's giving our site-based teams more time to manage the job rather than managing the reports and everything else that's going on. If they know that an area is being watched in real time and they're triggered an alert on their phone, they can go and check something out when it happens, not waiting for that phone call from the council or a client to say, you've made too much noise, or there's a complaint about dust or whatever it might be, All of that sort of process takes a lot of manpower on site to manage after the fact. If we can capture and record and be watching it all the time, every time, and the machines are telling us, then that allows the guys on site to go and manage real problems like, hey, move your truck out of the way. I've got the next crane coming through, the next crane lift's coming through. And we're actually giving time to be more time on the tools rather than time in front of the computer, kind of managing all these sort of problems that are happening on construction sites.
Sure. And how about the contractors using this, right? Because we were talking, so the contractors are actually a big part of inputting this data during the course of a project. So it just doesn't magically appear because you have some cameras up, that's part of it. But as they're doing their job, they're actually showing progress reports into this data somehow. Is that right?
Yeah, absolutely. And I've got a work example at the back end, which is talking about the aluminium clad panels, ACP panels, made famous by Grenfell Tower fire a few years ago. Yep. And actually capturing site data as you're going, we're producing almost real-time reporting. So progress reports are being updated. There's no paperwork to fill out at the end of the day, because with a phone and a web-based browser, we can capture that information, import it straight into the Vault, and we can map all that information spatially. So we're actually gathering data as it's happening, and that's really changing the way construction is using information on site.
I think it's, it was such a horrible thing, that Greenfield fire that happened. But on the flip side of it, there's a lot of great research and data and information that's being looked at because of it. So it wasn't just something, it was something horrific, but some good's coming out of it. And I think that's a great thing.
Yeah, I mean, I've got a personal connection to that fire. One of my really good friends was on the board of the property company that owned the property when it went under. He only joined 5 months before it happened. Terrible thing, but you're right. There is a lot of good, really great stuff in the industry as a result. It's just a shame that we have to have, such catastrophic events to drive change in industry. And I guess that's kind of what we're trying to talk about here. Is it doesn't need to be catastrophic if we can get that incremental change happening a bit faster.
That's right. That's right. All right, everybody, listen, we are live on LinkedIn, YouTube, Facebook, and Twitch. Please hit that like and share button right now. Give me some thumbs up. Give Craig some thumbs up. We got a lot more information. We're only halfway through the presentation. But first, why don't we say hi to a few people? All right, we're going to be traveling all across the world today, it looks like, in this country. Andrew Seeley, afternoon to all from Texas. Gonna be a good one. Andrew Seeley is with G-Pod America. Good to see you, my friend. Jeff Conley is with us today. LOT, you say, listening ears engaged. I love it. Here we go. All the way to France with Henry Mickelberg in the house. Australian man shakes his head at the Twitch question at 3 a.m. Come on, everybody knows what Twitch is, Henry. Isn't everybody watching the Dave Cooper live show? If you're not, you're wrong. You should be. We got all kinds of great stuff and great guests on all the time. All right, Gilbert Meyer in the house. Construction technology will not advance until it reinvents itself by standardizing and incorporating automotive assembly technology. Man, appreciate you, Gilbert. Gilbert's all the way in Honduras joining us today. So good to see you, Gilbert. I hope you are giving the good fight there with MMC3. Thank you very much. Henry says, and this is true, he watched you already. I caught Craig on one of Martin Fenn's webinar. Martin Fenn was on Monday, everybody. If Henry's watching it, it must be good. So go back and watch it on Monday on our YouTube channel. Really cool stuff and definitely scoring high in the Sharing Secret Sauce contest. Yeah, I would agree. So this is awesome, and we're getting a really good inside look. Jeff Conley says, question, open source or proprietary development?
Yeah, at the moment it's proprietary, Jeff. Sorry about that. The future will be more open source, but it's quite proprietary at the moment, yeah. All
right, perfect. We're going to get into some more comments and questions as we move forward. Look at that, all the way from Twitch. There we have it. Greg Ugaldi joining us. Craig set the record with 3 a.m. I think that I held it with 5 a.m. Coffee with Dave while we were in AK. Yeah. No, he definitely beat you, Greg. If you do not know who Greg is, I always like to point this out, and people on here know who he is. Greg is the immediate past chair of the National Association of Home Builders, which is the biggest lobbying firm, or second largest in Washington, D.C. We like to have Greg on our show because Greg is also the person that updates the White House, senators, and everything else, and is always fighting for our rights here in the United States for our codes and how we build. So, Greg, thank you for tuning in. We always appreciate you. All right, Craig, let's get back to the conversation and your presentation, and then we'll get the questions and comments one last time before we wrap up here.
Yeah, cool. Thank you, Dave. So, look, coming back to this concept of a spatially connected construction site, and this is what really gets me excited. All that other stuff is kind of preamble, right? This is the good oil coming on here. So, taking this concept of spatial mapping and applying it to everything that we do makes real sense for us to do it. We can't solve all construction problems with digital outcomes. Yes, there's some discussion about automotive industry thinking, and I agree with that with a lot of stuff that's going on, but we need to actually solve real problems first. So before we try and solve all these future problems of things we haven't even thought of yet, we need to actually enable a digital playing field that allows the supply chain to land their digital innovations on. And we've got to get construction sites ready. You can see, sorry, I'm just having some issues here. On our website homepage, there's a lot of videos about a construction solution, connected construction and play. Please check them out. I didn't want to try and get sound working. That's the muck around with sound getting this working today. But please go to our homepage and just check those things out. And you'll see that New Zealand Strong first connected construction site, which was our prototype one that we did a little while ago. Okay, there's many different permutations that we can plan for, and we've got to map this out at the start, right? Poor planning equals poor execution. So we don't own these devices. Remember, we're creating a space for industry partners to land their digital innovation on. The permutations of Internet of Things or IoT sensors help us plan how a site might operate more efficiently. Easy wins for us are environmental sensors, which are cheap and more commonly understood. Quite often they come with conditions that have to be satisfied through planning conditions or restrictions, and typical ones are like dust and noise limits on a construction site. Vibration is another one. We use our toolkit of families to help us plan these locations, not just on a map, but then we spatially locate them throughout the construction site. So we start mapping our tracking the spatial progress right from the outset.
Wow.
And we schedule, document, and ultimately price the solution in a hands-off manner. So the power of choice needs to be placed back in the hands of the contractor and the supply chain, not held steadfast by us. By measuring and monitoring and comparing against the digital solution, we begin to enable surety in what state the site will be in at any one time. And that's a definition of data provenance right there. And we can talk about data provenance later. This is, it's actually some, I hope it's going to work. Yes. Are we working? There we go. There we go. We got some stuff in. So what you can see on the screen here now is that video capture. We've got some exclusion zones set up here in the middle screen. So effectively, it's an area that we don't want people to walk through. When someone does, there's a trigger, and we teach the cameras how to do that very thing. We've got chutes here or down below it, which are kind of in there measuring when they're in their safe state, and then we're notifying as they're moving when they're in the kind of unsafe state. We can do number plate recognition. We can do personal protective equipment recognition, so we can check to see how the site is working in terms of safety. We can look for areas that might get congested in terms of flow of people through them. And in the top left-hand corner, we've kind of created the digital crane movements on the site and just checking how that could kind of work. And this is a prototype site that we got going, and a number of things came out of this. One really an interesting one, when there was a noise complaint on the site, and we were actually able to locate and isolate where that complaint came from. And it was a bus at 6:20 in the morning. It wasn't our construction site working that made the noise. And that just made it easy for the guys that day to tell the council worker to go away.
Yeah. You know, Craig, if I may on that, if you go back, I mean, this is something, a lot of people don't know this about me. When I was in the military, I did a lot of security work afterwards and some consulting in the Middle East with some companies that were using cameras such as these, like casinos, like high value areas. So this digital mapping and being able to like pick and understand what these data points is real. And it's been around. This isn't something new. You've just now taken it and incorporated it into the built environment, which is allowing you to catch all of this data in real time and activate only when it needs to activate. Is that accurate?
Yeah, pretty much. And it's all web-based viewer stuff, right? So again, there's camera views all over, but you've got to load into the camera app, and then you have to load into this app, and you have to load into that app. And what we realized is this opportunity to just bring those streams together. You could view it all in one place. I started to add a lot of context for construction sites to see what was happening. And I'll get into event triggers and stuff and how we look at that. Because again, there's no point watching these guys walk through the space all day to see if something's going to go wrong. You want to know when something happened, and it triggers an event and tells you. And that's really kind of where we've got to move to.
Yeah, for sure.
Okay. So this is kind of, again, now we're starting to get into what the what this vault looks like on the screen. Just bear with me. So the home screen is really the viewing where the sort of day-to-day viewing kind of takes place, and we start to see different technologies here playing together. The menu on the left-hand side here, we can bring up all sorts of different things, IoT, sensors, photos, model viewers, all that sort of are available to us at the click of a button. The weather app that we have coming in here and feeding, this is the weather app that everyone's using on site, and we've just got a record of that being captured day to day, so we can kind of see how things are transpiring. You see in the middle here, we've just got a basic pie chart from Occupational Health and Safety app that they're measuring the numbers of visitors on site and the number of companies that they're at. If they want to go into the health and safety data, you go into that app specifically, right? But if you just want that general overview view, you start to bring this information together. We've got site information about where the site's located. On this side here, we've got a whole bunch of IoT sensors that are measuring a bunch of things. We can start to look at the security camera feeds, and these can be triggered to show us something when there is an event, and we have notifications kind of coming out. This is highly configurable that we're starting to think, what does a contractor want to have available to view as they're going through the process of building something on site? When we start to get into more specific items or areas, what you've got here is the noise sensor, and we can start to locate where that noise sensor is on a general arrangement plan. And so we can now, when that noise sensor goes off and there's a trigger point, the light will change color, and we can actually see which one of the sensors went off because we've got it spatially located.
So is that just a sensor that's on a camera, or are you actually putting microphones out around everywhere?
Yeah, well, I mean, there's a lot of technology there. So it's microphones, cameras, vibration sensors, tank level sensors. We've got crane hooks that are being, monitoring as the crane hook is going up and down and where it is relative space of time. It's all data feeds that we give it a reference point being the location, and then we can start to show it. And I think this is the great unlock to be able to actually visualize kind of what's going on. When we start to get into other things, so looking at camera feeds, this is talking about event triggers that I was mentioning before. So this is like a camera still that you got here, and you can see on the right-hand side here, we've got the view of what the camera might be looking at. We're not really interested in the 14, 18 hours a day that it's not showing anything. But when something goes off, we want to be able to review when it caught something and what happened at that point in time, because we want to review that data going back to see when an event did happen. So again, it's taking the thing of a basic calendar, lining it up with a view of a camera and placing it on a map so you can see what happened and where, and then you can go back and review the footage. Really good for security issues or if there was an incident.
Wow.
We, in terms of site photos, how many photos are on people's phones, or they have to go back and rename under all the file naming on servers to save them against that project, against that level. And that is just counterintuitive, really, when every photo that you take has a time and date stamp on it. And if we know where you took the photo, then we can reference that back into a drawing. And every time you take a photo back there or near there in the future, we can go back and review that footage again. So photos for us become located inside the actual site itself. No need for a file naming convention. This is on level 2. That's the photo I took there. I click on that sphere and you'll see that later. And we can even do comparisons between side by side.
Okay.
We've got a side-by-side view, which I'll show you a little bit later, but there's industry partners doing better at this than us. And again, we're now offering them an opportunity to have spatial connections as well.
Mm-hmm.
On that project I talked about, we had a number of alerts coming up on mobile phones, and this just allowed the guys to have the information come to them rather than them going to the information, which means they can be alerted if something's going off when they're out on a different part of a site. And then they can decide there and then whether that's important or not, that they have to rush back to, or whether they're like, that's okay. I'll have a look at that later and carry on, right? So it's returning human time back to sort of construction sites is what we're talking about. This is kind of the number of applications that we've got just turn on straight away. And we can start to see that all the different things that you might want to start to have access to, where your IoT sensors are plan overlays. We can start to break down model elements. We'll start to do progress comparisons. We're starting to build this out and build it out and build it out as guys want more and more from these technologies. So let's talk about the great unlock, and this is kind of bringing it all together, really. We've got to apply this to everything that makes sense for it to do it to, yeah? There's a lot of people that are pushing great products out there, but they've got no real value or no real use. And I've got a favorite saying. It goes kind of like this. It says, the concrete really doesn't care after it's been poured. It doesn't care while it's curing how it was poured, right? It makes no difference to the concrete, right? So if you've got some great concrete app that's telling you about all sorts of stuff, the real concept there is you can do this 100 different ways, but once it's in place, it kind of doesn't care how it got there, the structure itself, right? So we need to solve real problems first before we can solve things that we haven't thought of yet. And that's why we've got to keep digitization going all the way through. This is what I was talking about with the side-by-side photo compare. This is a photo that was taken. You see a time and date stamp here, and we locate that photo where it was taken. And you can see here in our vault coming into play. That's just a little video clip. So we've got a 360 photo that we've taken here of it, and we're doing a side-by-side comparison now of the dates now 2 weeks later, looking at the same photo. You got the walls enclosed, you got other stuff going in, you got doors and window frames and that coming in, you got mechanical plant that's being finished off. We're starting to have a look at the data sets together. This has got real connotation for at distance construction sites. You can't always get to a site with a 10-hour drive in Australia to see what's happening on between sites every day. And now we can compare what we're looking at. So
let's stop right there for a second, Craig. These photos, who's entering these photos in 360 in real time? I mean, is there a project manager doing this? Is the trades uploading their photos?
This is the guys on site that are taking these photos as they're doing their job. And if you can imagine, they want to take a photo of their progress so they can show their boss, so they can show everyone else where they're up to on the process, right? And when we start to think about spatial mapping and really start to think about progress claims, imagine paying milestones against the wall being enclosed, versus what you do at the start of the month to the end of the month.
That's right.
And you start to add some of these sort of progress claims against payments against these things. If we can get the money to flow faster, because we got evidence and proof that you've done what you said you've done without walking the site every day to check on your progress, you start to add some real value to a construction site.
Yeah, and to the trades who want to get paid.
That's exactly it. And when this land of modern methods of construction, the supply chain is still carrying a lot of the risk, right? Bearing a lot of the risk all the time. This is here just something cool that my guys didn't realize what they'd done when they did it. So we just realized that we could take the IoT devices that were sitting inside dozers and graders and trucks on site. And then so we can now map their spatial movement through our GPS tracking around a construction site. And then they said, if I added the program down the bottom, would you want to map actual progress versus daily progress on the program? And I was like, who told you to do that? They said, we just thought it would be cool. This is software developers. I love them to death. They don't know why they're doing stuff sometimes, but it's still cool to be part of it.
So they have a Gantt chart that they can compare against a real-time Gantt chart, is what you're saying.
That's exactly it. And if you think about supply chain now, if you're bringing in, this is a civil project, you're bringing in a truckload of dirt and you land it, because you know where you've landed it because you've got the GPS location of the truck and you know where the dozers and the graders and the rollers have moved it all around, you can almost have automated progress updates as you're going through, mapped against the day you did it and to see if you're on program or not. I mean, this is a little bit conceptual, but the theory behind it is really, really sound.
Yeah, that is.
Using spatial mapping again. We're working with DFMA suppliers. This is an assembly put together by a company called PT Blink over here in Australia, who are really trying to change the way that structural building structures go together and just clip and connect and pour the concrete and off you go. But really, it's how do they land their kit of parts on a construction site, and then with all their different supply chains building up the assemblies for that kit of parts, how can they get paid knowing that they've built the part that goes in that position on that site at one time? So once you start to land items spatially, and we've got some assurance in those data sets that, yes, I built that tray for that environment, then progress claims on DFMA and kits of parts can become a bit more of a commercial reality. I want to give you an example, actually, Dave, if that's okay. And this is back to that sort of ACP panel stuff and thinking about the replacement of panels on the side of a building. It's spatial intelligence mapped as sort of data provenance. So it's kind of replacing spreadsheets and drawings and thinking about using a map. If we take logistics thinking of parts and assemblies that the supply chain use all the time, and we think about this whole concept of landing them on a construction site, and we can track and trace each milestone as it's gone through the process, we can use global technologies like QR codes, which everyone in the world has pretty much learned how to use during this COVID period. And so we now open our own way up to access how to pay for compliance. That P2 has reached the stage of this assembly, AO1, AO1's on the truck, and now AO1 has been erected and installed on site. This is when you start using spatial to get payments flowing. is start to check on payment for progress and also a payment for lack of progress as well. Thinking about ACP panels, you got to think maybe sometimes in a different way. And this is a hand-drawn sketch of a building that I did once when I was trying to think about how could you map thousands and thousands of panels on a building that had to be replaced. And I kind of went a little bit left brain, right brain, whichever the creative one is. But if we imagine a building covered in ACP panels that has to be replaced, it's just a bunch of canvases ready to be repainted. We can transfer progress updates to be visual reporting. So we can map milestones according to the build process stage. And in this stage, the different colors define the different stages of the replacement of the panel process. We're going to produce mass amounts of data because we're going to take photos, we've got forms, we've got sign off. But if you can put them all into a picture, then that becomes useful information. It's a simple idea and it's incredibly engaging because we digitize the current process and then we replace it by adding a visual marker on where we're up to in that process. And now you can communicate that process using color maps as opposed to, sheets and file structures and things. So we take that same sort of thinking and then we use that on sort of what we do down the physical swim lanes. And this is that process kind of redefined. Has the contractors going to use it? You've got what's happening at site in terms of measure, what's happening at the factory in terms of make. And then once it arrives on site, panels are removed. We're checking for seals. And every time we're taking photos, gathering that data, proof of what we've done. Why that's important is we're almost building up, I call it a visual blockchain of data set. Yeah, we've got a record of what's happening at that panel at that time, captured. If there's any defects identified, we know exactly where it is and what's happening. So it's each individual panel, we're capturing all of that data sets together.
Wow.
And this is kind of what it looks like when it comes together. So this is a building that we're actually working on now. It's 26 stories high. It's got about 4,500 panels that we're changing. And we've actually mapped the different stages of the replacement process to, this is using a Power BI dashboard simply to represent the data sets that we've got, right? It can be 2D. It doesn't have to be a 3D model. We just had one here. But we can now check visually the different stages of where we're up to on the process. We can even go down and do an audit, a spot check on an individual panel and see where it's at. We can look at a whole facade and see where the different individual stages are at. And what this is bringing to bear is we started to add and map that spatial intelligence kind of together. And then I'm going to come back to this Melbourne cricket ground. So what you're looking at now is this concept of a 161-year-old facility that seats 100,000 people on game day. And what they wanted to know was how are the people moving through their facility at any given time during the day. So we've just taken all of their existing camera feeds. We've done a little bit of AI and mapped as the people are moving into the different bays. And we've got a timeline as the ground is filling up. Because we've got the internal all spatially captured as well, we're now able to land point of sale data, including bar spend. So we can track how much money is flowing through the stadium at any one point. If you can see my mouse, none of these cameras and things that we have are our own. We're starting to zoom in on this camera on the top right-hand corner here. Now we'll start to bring in live data into a point cloud, and we can start to track how people are moving around that stadium. And we're recording this as we're capturing it as it's going through, right? And we can
I got a question for you. You said you can capture how much money the stadium is generating. And my guess is, from my newfound knowledge of what you're doing, they can also see when they're losing money because maybe there's too much congestion in an area or people are not spread out enough to spend their money. Is that part of this, where they're actually able to capture that data and actually see what's affecting or not affecting the real-time revenue gains?
That's exactly what's happening. So they know that they know that the money's being spent. If you think about the camera feed overlaid with the money being spent, and the bar goes red and it's 5 people deep, they're thinking, how can I get more people to get more beer in their hands so they can get back and watch the game rather than spending the time at the bar? And it's really changing the way the Melbourne Cricket Ground and other stadiums are starting to think now, who have contacted us. Guys like the Clippers and our other stadiums are talking to us about this very thing, because they're really about the experience of watching the game. Sure, they want to generate revenue as they go through, but they want to improve the experience of you being in their stadium because they want you to come back. Right? That's right.
Wow, that's really cool.
So that's it. That's the presentation. I just wanted to throw a few ideas out there, but this concept of spatial is very, very different. And We can to quote Lewis Carroll, we can go down a rabbit hole if you want to, Dave, but from Alice in Wonderland. But yeah, I mean, it's a really amazing way to think about what we can do with information once we start to locate it. Yeah. And if you think about what we can do with the information now, it's only a fraction of what we can do with that same information in the future. And if we know where it is, it doesn't matter what platform we're using, that's a way to really kind of unlock the use of that stuff in the future as well.
Yeah, I guess, using the digital technology of, I guess IP or AP cameras, or I think are the IP Internet Protocol cameras, I guess is what they call them. And being able to capture that data in real time with the built environment, I think is pretty amazing. And I'm imagining all of this could also be incorporated into panelized construction, modular construction, mass timber construction. In fact, it's almost, to me, made for that in some aspect.
It's absolutely made for that, because I mean, you guys now are doing all the 3D modeling and figuring out how all those bits go together and clip and connect.
Right.
And we can take that model and land it on like a platform like Vault. And as you finish off the components, as you're building them in the factory, whether you're scanning them, coding them, whatever it might be, we can map that in the final product model, and you can actually start to build up an iterative picture of, before you've turned up at the factory, this bathroom pop's finished, ready to go. It's had all its QHX, it's ready to land. I just need you, Mr. Crane Driver on site, to be able to pick it up off my truck, to put it there so that you can pay me for it. And it's a different way to think about, rather than sort of end of run getting paid when it hits site. If you've got the proof of all that stuff being done right from, turning the first screw until finishing the first wall, there's a way for you to have that sort of proof that you've built that element for that specific point.
And bringing all this data in, I mean, it can be brought in through CAD, through BIM. I mean, for the most part, can it bring in any software people are using, or is there any limitations?
There's no real limitations once we look at the reference point that we're trying to bring it to. And again, like I said, it's got to have some value for a reason for doing it. Just don't add 100 different platforms on there that you'll never use ever again, because what's the point, right? You spend all that time developing and no one ever uses it, and there's lots of platforms that live in that die after lots of money being invested in all that sort of jazz. So yeah, look, it depends on the data that you're trying to capture. We're focused on construction. This can kind of go anywhere.
Sure.
That cladding stuff, the real money in that is going to be insurance companies of the future, because if they can prove that everything's being built appropriately, they can get back to really clean insurance for building insurance, right? They don't want carve-outs. They don't want all the stuff taken out because you've got the wrong materials on the outside of it. You've got the proof of everything being there and captured. It's going to make things like insurance maybe lower in the future, premiums and things. I'm not sure.
Well, I mean, it should be, especially when you incorporate it with blockchain and other things where, there is no pointing fingers at this point. It's real-time data. Everybody knows who did it right or who didn't do it right and where something went wrong. So it should lower your insurance, because it's gonna tell a story that can't be modified. Yeah,
and look, it's a language. This whole concept of sort of provenance with data being built up from a construction site. You know where it came from. You know who made it. You even know the installer that put it in there. That's all been captured anyway. If we handed that over as a documentation record to the end client or the user, and they know that they've got it, if there is a problem in the future that we find, like a product recall on the automotive cars, the brake discs are faulty, we know exactly which wall was made wrong or had a problem with it, and we can be proactive in that regard if we know it's a real issue, rather than just waiting for the next building to fall down sort of thing, or the next fire to go up like Greenfield.
Right. Yeah, no, for sure. And then what about cost? How does one get involved in this? If somebody wants to reach out and say, hey, I want to use this product for my business, tell us where currently you are and where you're working, but also, how is the fee basis, being set up to use this software?
Why do interviewers always ask about cost, right? I've just shown you something amazing. You just want to know how much, right? So
because everybody's going to want to know.
Everybody wants to know, right? How much? Yeah, look, it's $1 million a minute. That's what I think the value of it is. No. Look, we're currently so we're quite established in New Zealand, and we're really growing in Australia. We at the end of this year, we're looking to do some movements into the US and into Europe. We're not there at the moment, and we need that proper support to be in place. Otherwise, it just falls over, and then it becomes something that somebody thought was a good idea. Cost of it's actually relatively cheap, and our view here is not to overcharge for this, because if I'm on 10,000 construction sites versus trying to make my money off 10, it makes it useful for everyone kind of out there. So we're talking in terms of prelim cost, that might be anything from sort of 10 to 20 grand a year. And that's adding all those different data feeds going onto it. So for a $100 million project or a $5 million project, it's quite expensive for a small job. It's not expensive for a big one, but we're starting to get into factories and things now as well. And there's all sorts of different pricing structures. The intent is to not be cost prohibitive. We know we've got something pretty cool, but it's no point being the cool kid and no one knows about it. So we'll keep the price low and we'll get it onto as many sites as we can.
And what about case studies? I know you're still kind of, newer in all the research that's probably going into this, but are you guys working on some case studies on the savings this brings to people?
Yeah, we've got some contractors who are really starting to get on board with this now and starting to gather those data sets for us. So we'll have about a dozen sites working here in Sydney by the end of this year. And the contractors are telling us it's actually the really interesting piece is the amount of time it's giving back to the guys. Knowing that information has been captured, that peace of mind, it's hard to measure peace of mind.
That's right.
But knowing that they can go back and review, that's one of the data sets that's come out, which we were all thinking about efficiency gain, 1.6% better. But actually the guys on site don't care about that. They're more about, I know that the data has been captured, and if there's a problem, I can review it. And for them, that's a great peace of mind to just get on with their job because they've already got enough to do on a site, right?
Well, and that's it. I think it'd be great to be sitting in Tahiti with a cocktail and be able to turn on my computer and see exactly what's happening on my job site whenever I want. And there's some amazing things to this. And time is valuable and big money when you get on these larger construction sites, any site, but especially on a large construction site.
The web you mentioned about being on Tahiti and a beach, that's I'm not sure if the genesis of the company started there or not, but the concept of being able to dial and have a look on web-based browsers is really, really important. Because you've got to make it easy to access. If it's not easy to access, the barrier of programs and software and tokens and all this sort of stuff, it'll really inhibit our industry kind of getting better, So we think that the spatial reference point, there's a bit of IP right there, is the great unlock. A file naming convention never helped the guy tying rebar to know that the drawing number he was using was a better drawing number than the one he used before, But to go home half an hour early knowing all his paperwork is done, that's awesome.
Yeah, right. And wouldn't it be great just to shut your computer at the end of the day and be able to enjoy your family and other parts of life? So I guess there's a give back of time on many fronts, maybe not even monetary, but maybe just with family and other things that has to happen. All right, Craig, listen, we are at a wrap. We're at 1:06. You did a great job. The presentation's awesome. I think the information is awesome. And I'm so happy to see somebody pushing the envelope and doing it better and bringing all this technology into the built environment because we need it. We're in last place, with agriculture there, and there's no need for that. This is where most people spend the most time in their lives, at work, in buildings, in houses, whatever the case is. We should be analyzing it. We should be building better. We should be building healthier, and we should be using our resources to do it with environmentally friendly and more data is going to help us get there. Yes.
Yeah, it sure is. So, thanks very much, Dave. I really appreciate it being able to reach out to your audience and hopefully I've showed them something cool. It's always hard to gauge, but I'm. It's 4 a.m, but damn, I'm excited, right? So
that's it. Well, that's it. Hopefully not too excited. You go back, get a little bit of sleep, get your day started, or just keep going. But all right, everybody, listen, that is a wrap today with Craig Lamont. Please join us Friday with Mark Bare Naked Willie and I for BS Friday, Building Science Friday. I will see you Saturday morning coffee with Dave. And Monday, well, it's a holiday. We're taking a break, so I will not see you this Monday, but be sure to tune in on Friday. Craig, do not go anywhere. I'll come right back to you after the outro. And everybody else, hit that like and share button one last time, and please subscribe to Craig Lamont. And if you are not subscribed to Craig Lamont and As Built, you're wrong. Go there and do it right now, and also subscribe to our YouTube channel. We'll see you next time. Thanks, everyone. Thanks, Craig.
Thanks, Dave.